Hi, you guys. Okay, we're going to do our last section in Unit 4. This is going to be on inverse functions. So we're going to learn what an inverse function is and how to graph it and how to find it. So let's go over those. Let me share my screen. We'll get going. Okay, so first of all, we've got a function and its inverse are a reflection across the line y equals x, okay? So in order to graph an inverse, we're going to find 3 points on the original. We're going to switch x and y in those points, and then we're going to graph the inverse and make sure that it's a reflection across the line y equals x, okay? So you're going to write this down. A function and its inverse are a reflection across the line y equals x. And then to graph an inverse, find 3 points, switch x and y, and then graph them, okay? So some examples would be like this. So if I have a graph and I want to find the inverse graph or graph the inverse, so the red one is my original graph, okay? So I'm going to find 3 points on the graph. So this point right here is 1, 0. This point right here is 4, 4. And then this point right here is 5, 8. So that's on the original graph. So then to find the inverse, I switch those around. 0, 1, 4, 4, 8, 5. Okay, so these are my new points right here. So I'm going to go to 0, 1, I'm going to put a dot. And then 4, 4, I'm going to put a dot. And then 8 and 5. So that's about right here. I'm going to put a dot. And then I'm going to connect those together. Okay. Now I'll notice that this line right here, this is the line y equals x. And my graph is going to reflect across that line. So it's going to be the same distance on either side of that line, so that if I turn it this way and I look at it as a reflection, then it looks like that. Okay. If there's a point on the line, then they would share that point in common. Okay, let's do this one. So here I've got a point. It's not quite 1, or it's not quite 0, and then it's up to like 3.5. So let's say 0.5 and 3.5. And then we have this point that's on it, so I don't need to actually write that down. It'll be the same one. And then we have this point, which is 8 and 6. Okay, so the inverse is going to be 3.5 and 0.5, and then 6 and 8. So I go over 3.5, so about right here, and then up a half, so it's barely right there, okay? And then this point that they shared, I'm going to keep that one, and then the 6, 8. So over 6, up 8. Now I notice this is the starting point of that graph. So the one that's reflected, I'm going to keep that as the starting point. And then this is going to go up and it's going to continue. Okay. So again, if I look at my inverse, it's a reflection across that line. Okay. So down here, I could kind of say, okay, this one, if I'm going to do a reflection, this looks like this. So this one's going to go like this, right? And then this is going to kind of wave. It's going to come out, and then it's going to get a little bit closer, and then it's going to start going away like this. So I can kind of get an idea of what it's going to look like. Okay. Now I need to write points. So let's say that this is -4, 0. So then this is going to be 0, -4. So about right here. So you can see that that's the same. Okay. Here we have 0, 1. So I'm going to do 1, 0. And then here I've got 4, 8. So I do 8, 4. Right there. So I'm going to have these 3 points, but I still have to kind of have an idea of how this shape is going to come together to reflect across that line y equals x. Okay, here's another one. So here I'm at 0, 1. Here I'm at negative 3.5 and 6. And then here I'm at negative 4.5 and 9. So if I switch that around, I get 1, 0, 6, negative 3.5, and 9, and 4.5. I think this was supposed to be negative 4.5, so the 4.5 stays negative. Okay, so 1, 0, 6, 3.5, and 9, and negative 4.5. Okay, so it was negative 4.5, and then it was up 9. So instead of being at negative 4.5 and 9, I go to 9 and negative 4.5. Okay. So one thing that you're going to notice about this is that that's not on here. So I'm just going to follow this graph. So if I look at this, is kind of going like this. It's just barely arching like this. Okay. I think I put this as a positive and it was supposed to be down here as a negative. Sorry. So we're looking like that. One thing that I wanted to show you is if I have a point negative 1, 2, when I switch that, I don't change the negative. I'm just going to move this to the other side. So it's going to be 2 and negative 1. Okay. A couple of things that are common errors is do not reflect across the x-axis. Okay. And do not reflect across the y-axis. Okay, so that's a common mistake, is to think that you're just going to flip that over, but you're not. You have to draw the line y equals x and then draw the reflection using some ordered pairs. Okay, so that's for graphing, but what happens if I have an actual equation like this? I'm going to switch x and y, and then we're going to solve for y. Remember that f of x is the same thing as y, okay? So if I have an f of x, this is my y. Just remember that. So when we do inverse notation, at the very end when we write down our answer and say the inverse equals, this is the notation that we use to show an inverse. It's that f to the negative 1 of x, okay? So to find the inverse, the first thing I do is switch x and y. So I'm going to switch x and y, so I get, instead of y, I write x. Instead of x, I write y. Okay, and then we solve for y. So step 2 is to isolate the y. So I'm going to get this term by itself. So add the 1 over. When I add x plus 1, I can't do anything with that. Okay, all I can do is just write them both because they're not like terms. We divide by 3. So y equals x plus 1 divided by 3. Now, we can write this as f to the negative 1 of x equals x plus 1 over 3. Okay. Another way you might see it, and different programs will accept different answers, but they would split this, instead of putting the x plus 1 over 3 like this, they write the 3 under the x, so that would be 1/3. And then they write the 3 under the number, so that would also be 1/3. So this way or this way, it's the same thing, okay? So when you're doing it on your homework, just know that there's a couple of different ways that you can enter it. And I'll take both of it on the test. Or on your homework work, it's fine. It's just when you enter it in the computer, you want to make sure that you check the answer and make sure that that's giving you the right thing. All right, so here's 3 practice problems. On these practice problems, we're not going to, well, yeah, let's graph them so that you can see how that works, okay? So x equals 2y, that's the first thing I do. Divide by 2, 1/2 x equals y. So this inverse is 1/2 x. Okay, so to graph the original function 2x, this has a y-intercept of 0. So I'm going to go to 0 and put a dot, and then we're going to do our slope, up 2 over 1. So rise 2 over 1. And once we have that point, that's all we need. Okay, like this. So the line y equals x is really close to this line. It's like this, because it goes through 0, 0, and then it goes through 1, 1. Okay, and then it goes through 2, 2. So the line y equals x is really close, but it's still off a little bit. So let's see if I do this. You can see that, okay? So if I'm going to graph the inverse, I'm going to do the same thing. I'm going to plug in a 0, and I'm still going to get 0, okay? And then if I plug in a 1, I get a half. So this one was 0, 0, so that's still going to be the same point. But then over here, when I plugged in a 1, I got 2. But this time it's going to be backwards. When I plug in a 2, I'm going to get 1. So 2 and 1 is right here. Okay, so when I connect these, it's going to look like that. Okay, now notice that this is the 1/2 x, and this is the 2x, and this is x. So you could see how it's right in the middle of those. Okay, so that's what you do when you're graphing those. Number 5. So now I'm going to have x equals negative y plus 1, subtract the 1, and then this is negative, so that means I have to divide by negative here and negative here. That's going to change. X divided by negative 1 is negative x, and negative 1 divided by negative 1 is positive 1. So my inverse is negative x plus 1. Look at that. So negative x plus 1 and negative x plus 1, this is the same line. So when I go up to 1, that's my y-intercept, the 1 right here. Okay, and then the slope is negative 1. So I go down 1 over 1, put a dot. Down 1 over 1, put a dot. And that's the equation that we get. Okay. So we took the 1 over, and then we divided by a negative, and we got negative x plus 1 when we switch the signs. All right, number 6. Let's add the 2. Okay, so right here I have 1/3 y, and I need to get rid of this 3 in the bottom. So to get rid of this 3 in the bottom, I times by 3, and that will cancel out. But then I have to multiply this whole thing by 3. So this actually is 3x plus 6 equals 0, equals y, right? So I'm going to write it as the inverse. So 3x plus 6. I'm going to put some lines on here. Okay, let's find 3 points on this graph. So it's going to be down at negative 2, so 0, negative 2. And then at 3, I'm plugging a 3 in because 1/3 times 3 is 1. So it's an easier number. You could plug in anything you wanted to graph that. Okay, you could even do your slope and go up 1 over 1, 2, 3. And you'd also see that that would be 3 and negative 1. Okay, so connect these. And then remember our, this equation, we do the opposite. So we're going to do negative 2, 0. And then negative 1, 3. So it's right here. So when I connect these, you could see they're going to cross way down here. And if I do that line, the y equals x line, it's going to look like this and come right through the middle of those, okay? So if I look at this one, let's draw that line, 0, 0, 1, 1, 2, 1. It looks like this, and it goes right through, okay? So I'm looking at that. So that's why it's an exact reflection of itself. The line is an exact reflection of the line y equals x. So that's why there's only one graph on that one. Okay, sometimes we do this with nonlinear. Okay, when we have nonlinear, we're going to go through the same steps where we isolate. Okay, so x equals negative y squared, and then this one is negative x squared where x is less than 0. So I'm just looking at this half of my x squared graph. So my points are going to be 0, 0, and then negative 1, 1, negative 2, 4. Okay, so those are going to be the points that I'm going to use for this one. So when I do this, we're dividing by a negative. So we get negative x equals y squared, and then we're taking the square root to get the y by itself. So negative x equals y. The square root of negative x equals y. So you might know that we never use, and this is plus or minus because it's an even, right? So we never have a negative inside except for if this is x. So if I have an x right here, I can plug in a negative 1 and I would get negative 1, and times a negative 1 I would get a positive. So this will work only if x is less than or equal to 0, right? Because then that will change that to a positive. So that's why we had to specify that specific domain, okay? So now I'm going to do this. So 0, 0. Now I only want less than 0 for my x. So if I think about how to graph this, I'm only graphing the negative part of the graph, okay? And so the graph, the positive one would be like this, and then the negative one's like this. This is the only part that I'm going to graph. Okay, whoops, I curved it the wrong way, sorry. I'm only going to graph that part, okay? And so if I look at that, it's off a little bit because I don't want to reflect across the line y equals x. I want to reflect across the line. I just said that backwards. I don't want to reflect across the x-axis. I want to reflect across the line y equals x. So let's put that line in here first. So let's see if we can get this on a different paper. Okay, so I've got this that's like that. And then we have this line that comes in like this. So if I think about how this is going to reflect, it's going to work to use these points and do the opposite, right? So I'm going to do 1, negative 1, 4, negative 2, and 0, 0. So let's go do those. So 1, negative 1 is right here. 4, and negative 2 is right here. Okay, so it's going to reflect. It starts at 0, 0, and then it's going to reflect across that line like that. You can kind of see how that's working. Okay, so don't try to guess that because this is less than 0, then this is less than 0. We want to use the points that we figured out, okay, and then it will work out. So just trust your points. Just trust your points that it's going to give you that right graph. Okay, so in this one, it's a little bit different. We have x equals negative y cubed plus 4. So I'm going to subtract the 4 equals negative y cubed. And then on this one, we're going to divide by that negative. So that's going to be negative x and positive 4. And then I can take the cube root. So the inverse is the cube root of negative x plus 4. Okay? And we're not going to graph that one. You won't have to do graphs of that complicated. So x equals the square root of y plus 2. I'm going to square both sides. I get x squared equals y plus 2. Then I want y by itself, so I subtract y. So x squared minus 2 equals y. So my inverse is x squared minus 2. Okay. So when I graph my original graph, this is x plus 2. This is a square root. So this is our root graph that's moved left 2. So I know the point negative 2, 0 is there. And then I'm trying to think of something that would have a square root. So if I did a 2, the square root of 4 is 2. So that's another point that would be on the graph. So negative 2, 0, positive 2, 2. Okay, so that's our graph. This is y equals x. Would actually go right through that point, 2, 2. So my inverse is going to be 0, negative 2, and then 2, 2. So it's going to be like that. Okay. All right, another concept is figuring out if an inverse of a function is also a function. So we learned back in Math 2 that if I have a graph like this, it's a function because it passes the vertical line test, right? So it passes the vertical line test. I always abbreviate that VLT, okay? So if I had another one that looked like this, that would pass the vertical line test. If I had a graph like this, that would not pass the vertical line test, okay? So just like we did the vertical line test to test if it was a function or not, we're going to do the horizontal line test to see if the inverse is a function. So if the inverse is a function, then it passes the horizontal line test. If it's not, then it won't. So this one would pass and this one wouldn't. Okay, consider the function 2x cubed plus 1. Determine whether the inverse of f is a function and then find it. Okay, so 2x cubed plus 1 is John Travolta because it's x cubed. So I know the graph is going to look like this. It's 2, so it's stretched, and then it's up 1. So I don't really have to do the stretch, okay? So this is the graph. Does this pass the horizontal line test? So if I draw a horizontal line, it only crosses it at one place. So yes, the inverse is a function. Okay, now find the inverse. Okay, well, I'm just going to switch x and y, and then I'm going to solve for y. So x minus 1 equals 2y cubed. Divide by 2 and take the cube root at the end. So we get the cube root of y and the cube root of x minus 1 over 2. So the inverse is the cube root of x minus 1 over 2. It doesn't ask me to graph those. Okay, you probably could if you wanted to sketch it. You know, you kind of go like that and graph the inverse. But you don't have to. Okay, here's another one. Determine if the inverse is a function. So this is right 3, and then it's a stretch, so it's going to be up a little faster. Okay, is that past the horizontal line test? Yes, the inverse is a function. You can hit pause while you write it down for a minute. Okay, I'll write HLT, question mark. So then I find the inverse. First thing I would do is divide by 2, so I get 1/2 x. Okay, then I'm going to square the whole 1/2 x. That becomes 1/4 x squared. Okay, then we add the 3. So f of x, f to the negative 1 of x, is 1/4 x squared plus 3. Okay. All right, the last thing that we're going to do is verify that f of x and g of x are inverse functions, okay? So to verify if two functions are inverses. Substitute one into the other, and you have to get x both ways. Okay, fancy way of saying what this is called composition. Okay, a couple of ways you can write composition. You can write f of g of x. This would mean I'm putting g into f. Okay, another way is writing f of g of x. This is the more common one that you'll see, especially moving on into calculus and 1050, you'll see both. Okay, so it means g is going into f. And then we're going to do the other way around as well, g of f and g of f. When I solve these two equations and simplify, I have to get x. So let's do f of g of x first. And then over here, we'll do the opposite, g of f of x. Okay, so I'm going to put g in place of f. So f says f of x is 3. In place of x, I'm going to put a box right here. Okay, so then I know that my function g goes in place of that box. So my whole function g, which is x plus 1 over 3, is going to go in place where that x was. Okay, do it the other way around. I write g first, so g of x equals my box plus 1, and then the whole thing's divided by 3. So look at that for a minute and see if you can see the difference of substituting f into g or g into f. Okay, so here I'm going to do this 3 will cancel this 3 out, and I'm going to get x plus 1 minus 1 is just x. Okay, so we simplified it. I should put a g of x right here to be more correct. Okay, here I'm going to put the f of x into here, which is 3x minus 1. So the top is 3x minus 1 plus 1 divided by 3. So I have to show this step that those cross off first using order of operations, okay? And then 3x divided by 3, those cancel out and we get x. So see how I got x on both of them? Yay, I got x on both of them. So yes, they are functions, or I verified that they were functions, okay? So I did 2 more examples of that for you on here. So we're going to do f of g of x and g of f of x. This is to verify, okay? F of g of x, g of f of x. So we're going to verify. I split this down the middle as 2 different problems, okay? So f of g of x, I'm going to write f first. So x plus, so box plus 5. And over here, I have a box minus 5, okay? This one, I'm going to put the g of x inside, so x minus 5. And this one, I'm going to put f of x inside. Either way, I'm going to get x minus 5 plus 5, which is just x. And here, x plus 5 minus 5, which is just x. Yay, I verified it, okay? So yes, they are inverses. Obviously, on yours it might say yes or no. You got to show the work to get your points, okay? So here I've got f of g of x. So f is 8, and then x is a box, and then my box is cubed, okay? Here I have the cube root, 2 times a box, okay? So I'm going to put my cube root of 2x in here, okay? And here I'm going to put my 8x cubed in here, okay? So this is going to cancel out, and I'm going to get equals 8 times 2x, which equals 16x. Okay, now over here, the 2 won't come out, but the 8 and the x cubed will. So this is equal to 2x and then the cube root of 2. So these are not inverses. Okay, now even if I got 16x here and I got 16x here, they're still not inverses. You have to get x. Remember, these two functions are reflection across that line, y equals x. So I have to get x for them to be inverses. Okay, all right, so that's what we're going to do for inverses. Finding inverses, graphing inverses and their function with the reflection line, and then verifying if two functions are inverses. Okay, have a great day. Let me know if you have questions.